So let's do a few more examples. Let's say we want to find the area of a region that's bounded by these equations. So we have y equals 1 plus the cube root of x. We have x equals 0, x equals 8, and then y equals 0. It's really nice if we can draw a picture of what's going on with this example. So if we were to look at this graph, and I'm using Desmos to graph this, we have 1 plus the cube root of x. Cube root of x can be rewritten as x to the 1/3. We see that it's the x cubed function shifted up 1 unit. So instead of crossing at 0, 0, because we've got that plus 1, it's shifted up to 0, 1. And we want to bound this by the equations x equals 0, which is the y-axis, x equals 8, and then y equals 0, which is the x-axis. So we're talking about this piece of the graph in this region, and we're trying to find the area for that piece. So when we integrate this, we're integrating from 0 to 8, since those are the bounds on the x-axis. And that's going to give us the area between that curve and the y-axis. They put y equals 0 in there, but that's unnecessary in this graph because by definition the integral is going to integrate and give us the area between the curve and the x-axis anyway. So our integral is going to go from 0 to 8, 1 plus the cube root of x times dx. So we are going to have to rewrite this as 1 plus x to the 1/3, and then we can use the power rule. So when we integrate 1, we get x. When we integrate x to the 1/3, we're going to add 1 to the exponent, and then we're going to divide by the new exponent. And then we're going to evaluate from 0 to 8. Let's simplify before we try to type anything in. So that's going to become 3/4 x to the 4/3, going from 0 to 8. So if we plug that 8 in, we have that minus, and then 0 is just going to give us 0 when we substitute it in. So I'm going to cross that out since that's going to be 0. So we have 8 plus 3/4. If we take 8 and raise it to the 4/3, we're going to get 16. So our final answer will be 20. So this is just another way of asking us to use that fundamental theorem of calculus and evaluate what that area would be between the curve and the x-axis. Let's talk about the mean value theorem for integrals. So we have a continuous function on a closed interval, and we're saying if this happens, then there has to be a number c in that interval, so that if we integrate from a to b of f of x dx, then it's going to be equal to f of c times b minus a. So let's talk about what this is actually saying. This is saying there's a place in here where the area under the curve is equal to the area of a rectangular region. So remember, to find the area of a rectangle, it's going to be base times height. So if we're looking at this rectangle, and I'm going to use this guy as an example, then from A to B, that would be the length of this interval, and then this would be the height of the interval, and that's our f of c. And they're saying in this case that C would be equal to this number, which is some number between A and B. Okay, our goal is to figure out what that C value is going to be. So let's look at an example. So we have number 47. We have f of x is equal to x cubed, and we're going from 0 to 3. So if we were to integrate this, remember what our cube root function looks like. Excuse me, our cube function looks like. Looks like this. Here's the value 3. So when we integrate this guy, if we were to sub a 3 in here into this function, we would get 3 cubed, which is 27. So this point is at 327. We're finding the area in here. So if we set that integral up, we're going to add 1 to the exponent, divide by the new exponent, and we're going to go from 0 to 3. So we're going to have 3 to the 4th over 4 minus 0 to the 4th over 4, which is going to be 3 to the 4th over 4, which ends up being 81 over 4. So there's our exact value, and we could turn that into a decimal. That's actually a pretty nice decimal. So that area between that curve and the x-axis is 81/4. Now, if we're going to use that mean value theorem for integrals, what we're trying to do is figure out what would that rectangle look like that would have that same area as 81 over 4. So remember, if we were to look at that mean value theorem, it says that that area under the curve is going to be equal to the area of some rectangle that has a width of b minus a and a height of f of c. Our goal is to find c. Now we know this piece. We ended up with 81 over 4 there. We know what b minus a is. In this case, it's 3 minus 0. We've just got to find c. And what this says is we're plugging c into that f function. So if we plug c in here, we're going to get c cubed. So let's solve this thing. So we have 81 over 4 is equal to c cubed over 3. If we divide both sides by 3, we're going to have c cubed is equal to 27 over 4. So now if we want to solve that, we need to take the cube root of both sides. I'm going to squeeze this in up here. So I'm going to rewrite. Now let's take the cube root. So our c value is going to be the cube root of 27, which is 3, over the cube root of 4. So this isn't a very nice number, but it's a number. We can actually simplify this a little bit more. Well, let's go ahead and get a decimal approximation for that. If we plug that in the calculator, I get about 1.89. I'm going to round the 2 decimal places here. So here's what this guy's saying. We're going back to our graph. The exact area under that curve is 81 over 4. 81 divided by 4 is 20.25. So what this theorem says, the mean value theorem for integrals, is that there's a place in between here, which is a c value. So our c value is 1.89, which is about here. So if we were to go up to the graph here, and we were to make this rectangle, that goes from 0 to 3. Same x values as what we had here. So we're going from 0 to 3, and we were to look at that. Let me change my color here. That area for that rectangle, it's going to have the exact same area as this thing under the curve, that red piece in there that we started with when we did this guy. So that's what the mean value theorem says, is that there's a place, if we have a continuous function and we can integrate it from a to b, there's a place in there where we could find the height of the rectangle that's going to have the same length. It's still going to go from a to b, where that area for that rectangle would be the exact same as the area for whatever that figure is under the curve. The next thing we need to talk about is the average value. So when we think about average, we usually think about the mean, and the mean says we add up a whole bunch of numbers and then we divide by how many numbers we added. So for an average value, it's sort of similar. We are looking at that area under the curve, and then we're going to divide it by how big it is, how big that a to b interval is. So let's look at this guy. We have f of x is equal to 4 times x plus 1 divided by x squared, and we're going from 1 to 3. So I'm going to first take this guy and I'm going to rewrite it. And then we know we can split the numerator. And then we can rewrite that, if we simplify it, as 4 plus 4x to the negative 2. So then our average value, we're going to look at 1 over b minus a times the integral of a to b of our f of x dx. So we're just substituting everything in there. Okay, what's nice is we've already simplified that before we started. So if we integrate, we're going to get 4 plus 4x to the negative 1 over negative 1. And we want to evaluate from 1 to 3. I want to clean that up before I start. So if we substitute the 3 in, we have 4 minus 4 thirds, subtract, and then we're going to substitute the 1 in. Okay, hold on 1 minute. When we integrate this guy, this is a 4 plus 4x to the negative 2. When we integrate 4, don't forget we're going to have a 4x. Be careful on that. So I'm going back in and I'm correcting that. So this would be a 4x minus 4 over x. So then when we substitute that 3 in, it's going to be 4 times 3 minus 4 over 3. Subtract. And then it's going to be 4 times 1 minus 4 over 1. Be careful with your integrations. So I'm going to simplify this a little bit. This is going to be 12 minus 4 thirds minus 4 minus 4. So we know 4 minus 4 is 0, so that's 0. And 12 minus 4 thirds is going to be 32 thirds. So we have 1/2 times 32 thirds, which is 16 thirds. So there's our final answer.